you aging faster or slower than your actual years suggest? Discover the truth with a biological age assessment, because your chronological age is just a number. Your biological age reveals the real story of how your body is functioning. Now, let's define chronological age and biological age and answer the most important questions associated with them. Chronological age is the number of years a person has lived since their birth. Biological age is a person's molecular age, how they function, and how fast their body ages biologically. Calculating chronological age is easy by counting years since birth. But to calculate biological age, you need to measure DNA methylation, telomere length, and several biomarkers for aging. The difference between biological age and chronological age can vary greatly from person to person. For example, a 60-year-old man who has lived a healthy lifestyle with good genetics and exercises regularly can be biologically around 45 years old. And the opposite is also possible. If the person lives an unhealthy lifestyle with poor genetics, his biological age can be 75 years old, meaning his body is functioning at an older level than his chronological age would suggest. Are there any visible physical signs of older biological age? Yes, there are some visible signs of aging that suggest a person is biologically old. Such signs are wrinkles, thinning skin, and age spots, lower muscle mass and strength, decreased energy levels and physical endurance, weaker immune system, poorer cognitive function and memory. The opposite signs can be seen when a person is biologically younger. Biological age is not a single value, but rather an estimate based on multiple factors, including DNA methylation, telomere length, and aging biomarkers. DNA methylation: when we age, methyl groups are added to DNA, affecting the function of gene expression and normal functioning. High levels of DNA methylation increase the risk of several diseases, including cancers, neurological disorders, and cardiovascular disease. There are several methods to define DNA methylation in laboratories, such as DNA methylation array analysis, bisulfite sequencing, and methylated DNA immunoprecipitation. It's worth noting that DNA methylation is a reversible process and is affected by many factors, such as stress levels, diet, and toxins. Second definitive factor is telomere length. Telomeres shorten over time and increase DNA mutations, damage, and the resulting increased risk of chronic diseases and cancers. Short telomeres mean an older biological age. Telomere length can be measured in laboratories using methods such as Southern blotting, quantitative polymerase chain reaction, qPCR, and fluorescence in situ hybridization, FISH. Now, let's talk about biomarkers that define biological age, oxidative stress and body inflammation measurement. For example, C-reactive protein is used to define inflammation in the body, while erythrocyte sedimentation rate and white blood cell, WBC, count are used to define the inflammation status of the body. The glutathione test is used to determine the oxidation status of the body because glutathione is a key antioxidant that helps neutralize reactive oxygen species. The total antioxidant capacity, TAC, test measures the overall antioxidant capacity of the blood. And now, let's touch on what predicts a young biological age and why it's important for humans. Factors that predict a young biological age include a healthy lifestyle, regular exercise, a balanced diet, no smoking, avoiding environmental stresses, and having a favorable genetic background. Of course, the last one is not dependent on us, but most of them are under our control. It is important to have a young biological age as it indicates a lower risk of age-related diseases and better overall health outcomes, allowing for a longer, healthier lifespan.